Hello, today I'll be talking about polynomial regression, which is part of the supervised learning branch in machine learning. And if you haven't already, I recommend you watch my previous videos about regression and machine learning. And so yeah, let's just get into it. So what exactly is polynomial regression? I'll just make a quick recap. Polynomial regression. So polynomial regression is a form of regression that we use to model the relationship between one independent variable x and the dependent variable y. So it's basically like linear regression, but obviously in polynomial form with curves. So um, and you might be thinking, why do we need polynomial regression if it's just the same thing as linear but with more curves? Well, like I talked about before in the linear regression video, relationships between variables are often more complex than just a straight line. Um, so yeah, you can think about a lot of different applications, like even how a plant might grow with changes in temperature. That's not going to be a linear relationship. So we're trying to basically better capture the various relationships in the world with polynomial regression. So as a basic equation, let me actually just turn Grammarly off. So the equation is basically going to look like something like, I'll just say A plus bx plus cx squared plus dx cubed, and so on. And yeah, it's just going to be the same thing you might have seen in your math class, which is just a polynomial equation. And basically, it's going to go until, let's say, like some coefficient, let's say z x to the n, or yeah, whatever. And yeah, technically it can just go infinitely to the nth degree polynomial. And so yeah, how does it exactly work? So how do we use this equation? So obviously we have our data set. Um, and it's going to look similar to the linear regression. So we have the data set, and then we have to choose a degree between for the polynomial, because obviously we can't just go to the infinity, so we're going to have to choose, let's say, we want a third degree polynomial to represent our relationship. So that's going to be the second step, so choose. And then essentially, once we choose a degree of the polynomial we're going to use, we can create different features for every single, I guess, term of x. So here we have a, which can be one feature, and then we have bx, which can represent another feature, and then cx squared, which can represent the third, and so on. So yeah, the good thing about polynomial regression is that we can basically factor in a bunch of different features in this equation. So create new features by raising x to different powers. And then what we'll do is we'll use these new features in the multiple linear regression model. Yeah, so once we have all these different features, and let me clarify like what features means. So in linear regression, our data set was just split into two. We had the input and the output. But now for the data set, we can have, let's say, x1, x2, x3, and so on, and then the output, so y. So we can factor in a bunch of different variables to get the input. And so yeah, once we have these new features, we can plug in the data and then find the y or the relationship with y in the form of this equation. And obviously there are multiple ways to do this that require some sort of optimization and cost analysis, but yeah, that we'll get into that later. So yeah, then find the regression model. Yeah, so polynomial regression has a bunch of real-world applications. We can use it in economics, biology, physics, etc. And yeah, it's just a very useful form of regression analysis. So let's talk about some pros and cons. So the pros, we have that unlike linear regression, it can capture much more complex relationships within the data. So capture, and yeah, this is obviously because we can take in multiple variables now, and we can, it's not going to assume that's just a linear relationship. It's also more flexible than simple linear regression. Like I said before, we can account for different, let's say, like, um, I guess, factors influencing the output. So with like the curves of a polynomial, obviously we can account for all of these much better than linear relationships. So it's more flexible than simple linear. And yeah, it's also relatively easy to implement and interpret. It might be a little less intuitive than linear relationships regressions, but nonetheless, more than other machine learning algorithms, it's pretty easy to interpret. So we can do implement. And yeah, of course, there are going to be cons. So um, uh, like the linear regression, actually polynomial regressions are even more easier, prone to overfitting in the data. And basically what overfitting means is that you're kind of like micro adjusting the model to every single, let's say, change in the data. And I'll talk about overfitting later in a video, but yeah, just know that it's very prone to overfitting. And similarly, it's sensitive to outliers because it's going to try and account for every single thing with all its various features. And yeah, so finally, exploration or predicting beyond the range of the data. It seems like we don't have space. And yeah, so exploration can be risky. But basically what this means is that once we're beyond the scope of what the data inputs and outputs were, it might not be, very safe to, I guess, use the model to predict. So let's say we're given x value or x values from 0 to 100. If we have an x value of, let's say, 200, it's going to be very, I guess, most likely inaccurate and risky to, make that assumption that the model can predict accurately outside of what the data is given. Because if you think about a polynomial, the ends are always curving exponentially downwards or upwards. And so, yeah, that's why it might be a little risky to use them to predict outside the range of the data. And that is it for polynomial regressions, and in future videos I'll be going over the concepts we cover in this in depth. But for now, thank you for watching.